And there you are. We can start looking at this nice emulator, please, Dave.
Thanks for inviting me. I know we've got different takes on emulators. Mine's going to be a little different. Thanks for having me again. My name is Dave. I'm in California near Silicon Valley. Had a Commodore since high school as a VIC-20. Experienced with a PET. Own a Commodore 128D. The Thompson monitors back here. Keyboards around here somewhere. But I've been doing a lot of stuff for the emulator. In emulation, I rewarded myself finishing a work project that I pulled out my Commodore 128D, got it working again. That was exciting. And getting back into Commodore has been fun. My claim, let's put that in quotes, to fame is I did get a publication in 1988 with Compute's Gazette for scrolling basic editor. I saw that on the Mega 65 you could scroll up and down in your program. But that's today. But back then it was hard to do unless you had certain basics allowed you to do it. So if you want to edit your Commodore 64 basic programs scrolling backwards and forwards, check out this old stuff. But we're going to go and proceed with the emulator today. My goal was a minimal implementation, bare bones. It turns out that the Commodore ROMs can be emulated with very little support. I went ahead and did the 6502 emulator and got the ROMs going up to speed. My initial attempt took about a couple days, and I got really lucky, really lucky. I was able to match things with Vice, do comparisons of traces, and when my trace wasn't quite right, I knew I wasn't doing the bit operand right or something like that, and I fixed that. And the reason I'm still playing with this thing is it's just an emulator playground, something to keep me busy. It's just fun for me, and I do a lot of what ifs and slightly different takes on things. The features, of course, it's open source. You're welcome to change it and use it. It's cross-platform. It's using C# as the language of choice. So Microsoft.NET framework. That should work on Windows, Linux, and Mac. I'm using Visual Studio on my side, but you should be able to use the .NET command from a console prompt to do it. This emulator is console-based. It runs in the like command.exe. It's kind of crazy. It's very minimal. It's doing the DMA host accelerated file access when it captures the intent to load a program. It does it for it, and it returns and doesn't really run the 6502 for that. It substitutes it for it, and that works on the and we'll get into that in a little bit. You do have scroll back history with the Windows console or the other systems, terminal console. You can configure more than 40 by 25. You can go up to 200 columns wide. So if you want to really have a good text-based basic program, go for it. This one is cheating. You can have multiple colors on the screen. You can have multiple character sets. I am leveraging a third-party font to do the PETSCII, and there's links to that on my website, of course. The trick that I added is to capture the Go command. The host emulator sees that someone is trying to do Go, and it can switch Commodore models. We'll show that. This describes some of the components. These slides are all online on my GitHub as well. The specific models it supports, we'll show that in a second as well. The walk ROM routine was one of the first features I implemented, disassembling 6502. Once I could disassemble it, then I started executing it. once I started executing it, I got close to a Commodore 64 coming up to speed, and proceeded from there. The walk command will go through all the branches and do an ASCII listing of the disassembly. A fun thing to do is if you want to figure out what a Commodore 64 does, or a PET or a C128 or whatever, you can walk a routine. Once it hits that last RTS, it's done. But every branch, it'll do both the path of the branch and without the branch, and keep track of that. You could pass that to sort command, and I've played with disassembling things and figuring out how things work. The ROMs aren't that big. If you want to know how IEC works, hey, check it out. It's all there. Others have done it, but if you do it yourself, you can get that memory, get that experience as well. The go command is what I added. Commodore 128 had the go 64, and I added the others. And I'm going to show you that in a second. By the way, this was hosted all inside the emulator, but you probably figured that out. This is a Windows console, so some of these look like regular Windows, and some of these look like Commodores. The difference is only the font. Inside a command window, you can change the layout of the number. This is standard Windows stuff. You can do it on other systems as well. Here's your physical screen, 40 by 25. Your buffer size, you can go up higher if you want and have a scroll back. And in the font, this one is actually using this thing from Style Pro, C64 Pro Mono. And that is how I cheat and display the font. Now, in addition to being able to launch these all separately, you can, I'll go back to the slides. This was in a Commodore 64. I'll show you 6. Let's do the sys command. We are using, got the full support. That, do a break command, you go back in. Let's go to the Model 1 PET. You can have 8K RAM. Actually, some of these are coded, so the Commodores probably wasn't quite sure how much RAM they were supporting. So they actually do RAM checks on everything except for the Commodore 128, and some of the TED series do a little less too. You can go up to the VIC-20. Now we have a 40 by 25 VIC-20, or as I showed you, you could reconfigure it to 22 columns. 64, it does prompt you for most of these systems. With the VIC-20, you can also go up to 40K if you want. And it's configurable on all the supported configurations of RAM. So the one trick we have is we can go to the Commodore 16, configure it for 16K of RAM, configure it for 32K RAM, or you can go up to the +4 with 64K of RAM. And with these basics, we have the new basic. This is the 3.5. So we have the do command and stuff like that. Let's go up to the Commodore 128. There we go. It also has the monitor. You can even do the RAM banking. Here we look at the character set. I'm sorry, not disassembly, but memory dump. Those are the bitmaps of the characters. We don't have a screen editor. We have a line editor. So anything that I've typed before, I can scroll back with the cursor up. I can access my fun stuff there. There we go. Let's look at a big screen. Let's go to 64. Poke. Get that readable. It's going to load a PRG file from the Windows file system. And here it is. And it's running full out for this one. And there you go. For more software and more emulators, I have a C emulator. I've done an LCD emulator with the USB keyboard on the STM32F429 Discovery board. Teensy with SD support for D64 as well, and a browser version for TypeScript. Most of those are Commodore 6. They're all Commodore 64 only. But I suspect that I will be adding more support for more ROMs in the future. Let's go ahead and open it up to questions.
I don't see any questions in the chat for the moment. I have one actually. How do you? So you access directly you said the file system from there? You need some kind of.
This doesn't have any virtual disks. It doesn't have a directory, so it's just if we do the load command, like I can load my machine code. I can even do paths. I've got it loaded. Oops. Like that. So that's an example. One tidbit is the Commodore 64 probably has this bug in it because I think it was originally developed to have 16K of RAM. So they probably didn't expect it to go over 32. I could be wrong. I could be exactly wrong on this, but so they didn't. They used it as a signed int. If you look at the Commodore 128, got 2 banks of RAM, so it's showing 2 sets of numbers there. This is good for just playing around with basic, but as well machine code that is text-based. There's no VIC emulation. The pokes are limited to like reverse and the quote mode and insert mode. And
but then if you're writing your own, if you're writing a program there, then you just save it to the disk. There is no tokenizing process or in the background, or how?
Yeah, it just does a DMA dump of the memory that's requested in the ROM routine to which bytes to save, and it just does an image of it to the disk. The PRG format that is supported by Vice is rudimentary. It's just maybe the first 2 bytes are the load address, but other than that, it's just a binary image. So that would be compatible with other systems in that way. If anyone has a need for D64 support, I do have code up on my GitHub showing that as well for a C version of the Commodore 64 emulator that is rudimentarily similar to this. I'm looking for a new name for this. I don't have a great name for this project. I go straight to the code. So stupid emulator comes to mind, but maybe there's something sweeter than that.
Okay. So there's something, I see more questions. What OS does it run on? So we know Windows, I guess.
Since it's .NET framework, I've run it on Chromebook in the Linux environment. I haven't tried the fonts in that regard, so I'm using it more as the text space, right? And it should run on the Mac, though I haven't tried that. But .NET is cross-platform, so it runs with either .NET Framework or .NET Core, either one.
Okay, thank you. I read the next one. Did you partially emulate other chips in order to boot the ROMs, or did you patch the ROMs to avoid needing the other chips?
I didn't patch the ROMs at all, other than capturing when the instruction pointer gets to a certain point, it might decide to, hey, you're trying to do this. I'm going to do this instead and just return, like the load command. For some machines, I simply return 255 for any IO space. For some, I return 0. For some, I did have to implement sub-hardware. The Commodore 128 was one of the most difficult. I did have to implement a VDC. It's actually emulated. It's just in the background. It doesn't display anything, but it is doing the VDC registers. You know how that chip only allows you can read and write. You can set the register address and you can read and write from those registers to access the 16K or 64K, depending on which model you have. That was required to get the Commodore 128 up. I had a similar bug of it coming up in the monitor and had to implement the state. So it's in a certain, so the IO returns a certain state. I did have to do MMU support for both the 64, or memory mapping, or MMU or PLA type stuff. For the 64, the TED series, and the Commodore 128. They're all different. It seemed that the bare bone systems from the PET and the Commodore VIC-20 and the 64 were pretty rudimentary, other than the memory banking. I originally had it implemented without the memory banking. It's not a requirement for the ROMs. As well as you can, if you change it to a 5K Commodore 64, that RAM is no longer there. So it's interesting. I've learned a lot about how things work in these systems. Started with the 64. That was my only goal. Went to the PET next. And I think the VIC-20 came next. The VIC-20 and the Commodore 64 have a very shared history, very close together. The VIC-20 has some shared history with the PET as well. They all build on each other. If you want the most program space, I think it is this +4 that gives you the most RAM available in the one bank. Whereas the Commodore 128 splits the variables into the bank 1 versus the other in bank 0. There is no support for a 256K Commodore 128 in the ROMs, I see. So I'm just having fun, as well as anyone should have fun with these. We're all having fun, right?
Yeah, it looks really good. I see another question. In what language was it written in? And then
it was written
C#.
in C#. Yeah.
C#. Yeah. Okay. 1 point for Dusty. He guessed that.
Yeah. And if you want to see any of this other stuff, head over to daveyw.com for my blog. There's three articles on this.
When you have new things, you come back, Dave.
I've got new things all the time. It's fun.
Good. I don't see more questions.
I have a question.
Please go for it.
Dave, are you selling the Teensy C64 emulator Teensy?
Oh, it's free, man. I mean,
it's free.
Well, you pay for the hardware.
Yeah, there we go.
The Teensy emulator is also minimalistic in that it's the Teensy platform. They sell an LCD. They sell a USB adapter that plugs straight in. All I have documented what the wiring is, so it's nothing proprietary.
Oh, awesome. Can you share a link to that in the chat here so I can take a look?
Yeah, go to davew.com. I will share a link. Yeah.
Excellent. Thanks a lot.
Thank you so much for the time.
You're really welcome. I will stop the recording now.